In section 6.2, we're going to look at another application of integrals. And what we need to look at first is just a refresher on what the demand and supply function are. And then we're going to look at something called consumer surplus and producer surplus. So first of all, just a reminder of the demand function is really the amount of money that consumers are willing to pay for a certain number of units. So typically we represent the demand function as d of x. And what that would mean is d of x would be the price, or the y value is the price. So it's the price per unit that consumers are willing to pay when X units are made available. So then if we talk about the supply function, that's typically represented with S of X. So S of X would be the price, or the Y value, and X would be the number of units. So the supply function is the price that the producers are willing to produce and sell their a certain number of units for, so X units. So this is the price per unit producers are willing to produce or supply X units. And then the equilibrium point is the point where the supply and the demand are equal. So this is when sales are actually happening. So this is the point where the supply equals the demand. And this point you're going to see is going to be represented with X sub E comma P sub E, meaning the little e's just represent the equilibrium point. So it's the number of units and the price at the equilibrium point when the supply and the demand are equal. So visually, let's just take a look at what that looks like. So if we have a graph here, and let's say that this is our X and this is our Y, or P in this situation. So this would be price on the y-axis, this would be units on the x-axis. If we look at our demand function, so demand is going to be decreasing. So something like this. So this would be our demand function, d of x. And then our supply function would be increasing. And where these two intersect, or where they're equal, this is called the equilibrium point. So again, this is X sub E comma P sub E. So this right here would mean X number of units. And then this would be the price. So if we start talking about consumer versus producer surplus, consumer surplus is when the consumer benefits. So it's the difference between the amount that the consumer was willing to spend versus how much they actually spent. So it's the amount that they didn't have to spend that they were willing to spend. So let's write that down, and then we'll take a look at what that looks like visually so you can see kind of how this all ties into integrals. So this is going to be the difference between the total amount a consumer is willing to spend and the total amount actually spent. So if we look at this visually, so I'm going to kind of sketch that same picture, but the difference is I'm only going to look at the demand function here. I'm not going to look at the supply since we're talking about the consumer. So if I sketch in the demand function again, and remember that this is the price over here, this is P, this is the number of units, this is X. Again, let's just say that the equilibrium point was somewhere right here. So I'll say that this is X sub E and P sub E. So it's the price and the number of units for the supply and the demand to be equal. The consumer surplus is this area that's bounded between the demand function and the price at the equilibrium point. So this region represents that extra money that the consumers were willing to spend but didn't have to spend. So the consumer surplus is this region. So think about if you wanted to find this area, think back to section 6.1, the area between two functions. So we have d of x as one function and p sub e is just a horizontal line. So that's really, you can think of that as a horizontal function. You can think about it as y equals some number. So if you look at this, the d of x will always be greater in this region. So we're not going to actually have to test to see which function is greater. But d of x will always be greater. So what we'll do is we'll take d of x, we'll subtract off this horizontal function, p sub e, and then we'll integrate between 0, because this is 0, to whatever that number of units at that equilibrium point. So that's where, if you look down below, where this formula comes from. So it says that the consumer surplus is equal to the integral from 0 to that x value at the equilibrium point of the greater function, which is the demand function, minus the constant. So that's where this comes from. So let's go ahead and look at an example so you can kind of see what this means and what this looks like in terms of calculating. So if we read this example, it talks about the demand for a particular item is given by this function d of x. And we want to find the consumer surplus if the equilibrium price of a unit is $250. So first of all, I read that, and that represents P of E. That's the equilibrium price. So P of E is equal to 250. Now, if you think about that formula, the consumer surplus formula from the previous page, so C of or CS, consumer surplus, is equal to the integral from 0 to x of d of x minus p sub e. Again, I'm just taking this formula right from the previous page. And if you look at what we have, well, we have d of x. So I have that. I have p of e. And now what I need to know that I don't have is x sub e. In order for me to actually plug in and integrate, the first thing I need to do is find x of e, or x sub e. So what I'm going to do is my first step here before we can plug into our formula is going to be to find x sub e. And the way to do that is, well, x sub e represents the x value, or the number of units at the equilibrium point. So when the price is equal to 250. So basically what we're going to do is we're going to take our demand function. So d of x equals 1450 minus 3x squared. And we're going to replace d of x with 250, because this really means d of x is equal to 250. So 250 is equal to 1450. So we're just going to solve this for x. So I'm going to go ahead and get this equal to 0 because I see the x squared, which means I'm going to need to factor or at least get it equal to 0 on the one side before we figure out what we're going to do. And then from there, I want to try to get a 1 in front of that x squared. So let's just go ahead and divide everything by 3. So we get 0 equals 400 minus x squared. And then at this stage, you have options. You can either do difference of perfect squares factoring, since you have 2 perfect squares. Or what we can end up doing here is just bringing the x squared over, or 400 over, whatever way, and solving for x. So what I'm going to do is bring that x squared over so it's positive. And then from here to solve, I'm just going to square root both sides. So I get x equals plus or minus 20. And then I'm going to reject the negative here because we don't want negative units. So it's just going to be x sub e is going to be 20 units. So that means the x value at the equilibrium point would have to be 20 units. So when the price is 250, the number of units is 20. That's what it's saying. So now that I have all three things, meaning I have the x sub e, I know the p, and I know the function d of x, well, now I can plug into my formula. So I'm going to go ahead and write down my formula for the consumer surplus. So it's always going to be d of x minus p sub e, because d of x will always be greater. And then and now I can plug in. So 0 to 20 are going to be my bounds. D of x, I got to go back up to the problem here. So that's going to be 1450 minus 3x squared. And then minus 250. And then from here, we just do our integral. So this just turns into an integral problem. So I'm going to just combine like terms before I start integrating. So I get 1200 when I subtract the 1450 minus 250 minus 3x squared. And now at this stage, we can start integrating. So I have 1200x minus 3x to the third over 3. And then we're going to just keep our bounds at the end. And before I plug in, though, if I can simplify this, which I can just divide the 3, so that 3 divided by 3 is just 1, so it makes it a little bit easier. So now I can go ahead and plug in. So I have 1200 times 20 minus 20 to the third. So there's plugging in 20, so I want to get that entire number. And then I'm going to plug in 0, which you're going to see a lot with these, that the second part of this will often go to 0, or when you're plugging in 0, it'll often, this whole thing here just ends up becoming 0. Not always, so just be careful, but a lot of times that will happen, just because when you're plugging in 0, the numbers multiply out and end up being 0. So then when I get this value here, the first value, I end up with $16,000. So that represents the consumer surplus. So that represents the amount, the difference between the total amount a consumer was willing to spend and the amount that they actually spent. So that $16,000 represents the amount that the consumer would have been willing to spend more, $16,000 more, than they actually had to spend. So that's kind of think of it as their savings. So then let's go ahead and, so that's the consumer surplus. So let's go ahead and look at the producer surplus. So this is benefiting the producer now. So producer surplus is the difference between the total amount the consumers actually spend for something and the total amount that the producers were willing to accept. So it's the extra money that the producers are getting from the consumer. So consumers are spending more than what the producers were willing to accept for the item. So this is the difference between the total amount consumers actually spend and the total amount producers are willing to accept for X units. So if we get a visual for this one, let's go ahead and sketch our axes here. So X in price, so this will be price, this will be the number of units, and this is going to be based on the supply. So if we sketch the supply function here, that's increasing. And then the equilibrium point, so let's say that this is the equilibrium point. So this is going to be X sub E. This is going to be P sub E. The producer surplus is this area right here. So this represents the producer surplus. And if you think about what this means, well, it's an integral because it's an area. And think about what we did in the previous section. So it's the area that's bounded by this horizontal line and S of x, the supply function. So P sub E, or this horizontal line, will always be greater than S of x. So that means that you would take P sub E and you would subtract off the supply function, and then you're going to integrate from 0 to x sub E. So if you look at the formula down below here, this time for the producer surplus, it's going to be P minus S of x. So P is first because that's greater, and then S of x is below it. And then you're going to integrate from 0 to x because that's the region that you're looking at. So that's where it comes from. Let's go ahead and actually try an example where you see all of these put together. So if you go to the next page here, we have an example where we want to find both the consumers and producer surplus for a product where we know the demand function and we know the supply function. Notice it doesn't say anything about our equilibrium point. And both functions or both integrals or formulas require you to know both the x value and the p value at the equilibrium point. So that means the first thing you have to do, if you think about your formulas, is you have to find x and you have to find p for the equilibrium point. And in order to do that, that's where d of x and s of x are equal to each other. So that's what we have to do first. We have to find that equilibrium point. We need to know our bounds for integration. We need to know the p-value because both are required in our formula. So our first step for this is going to be to find the equilibrium point. So in order to do that, that's where the demand, the demand is equal to the supply. So set the two functions equal. So we have 25 minus 0.005. Let me rewrite this so it's a little bit neater. So 0.005 x squared equals 0.004 x squared. So let's go ahead and combine our like terms here. So let's group these here. So let me just bring this over first. So we end up with 25 equals 0.009 x squared. And what I want to do now is go ahead and actually just divide by that 0.009 so that I can get x squared by itself. So let's divide both sides by that. And then we can take a look and see if we could factor it. Or since it's just an x squared, this should just say x. This should just have the number, not the x squared. So since it's just going to be an x squared equal to a number, I can just use the square root method, because if you look at what we have here, this fraction, you're not going to want to try to factor that. So what I'm going to do is just say that this is 25 over 0.009 equals x squared, and then just square root both sides. And then that way we can just type that in our calculator. And you're going to end up getting a rounded value, which is fine. It just means that we're going to have a rounded x and we're going to have a rounded p when we go to solve this. So this is going to be x equals plus or minus, you get 52.7046, something like that. Again, we're going to reject the negative here. So that means I'm going to say that x sub e is approximately equal to 52.7. I'm just going to round that one decimal place because I don't want to use this entire long decimal as my x value in my bound. So now that I know what x is, now that I solve for x when the two functions are equal, well, I still don't know what p is. So p is actually easy to find, because if this is the x value that makes these equal, well, plug that into one of those functions to find p. So in order to find the p value, you're just going to plug into either function. So plug x sub e into either d of x or s of x. It doesn't matter which one. So pick one that's easier. So I'm going to pick the supply function. It looks a little bit easier. So if I plug into s of x, that was just this, the 0.004 x squared. So plug in 52.7. So 0.004 times 52.7 squared. And again, this is going to give me an approximate. So 11.11 is my approximate for that. So then that tells me, so if this is P, this tells me the equilibrium point is 52.7, 11.11. So sometimes you'll have questions where it'll just ask you to find the equilibrium point. So that's what you would be doing. You would be stopping there. You'd say, okay, there's my equilibrium point. But for this question, it wants us to go further, and it wants us to find each of the surpluses. So the next step here, now that I found my equilibrium point, well, and I know my x value, I know enough information to be able to just plug in and integrate both and come up with values. So for step 2 here, I'm going to just do the consumer surplus. Not that it matters, you just pick one. So the consumer surplus, remember, is the integral from 0 to x of the demand function minus p sub e. So then we plug in. So 0 to 52.7. The demand function from the top of the page here is this 25 minus 0.005 x squared. So 25 minus 0.005 x squared minus p sub e, which is the 11.11. So then we want to combine our like terms here before we actually integrate. So 25 minus 11.11 gives me 13.89 minus 0.005 x squared. And now I integrate. So we get 13.89x minus 0.005 x to the third, divide by that new exponent, keep your bounds at the end. And now we plug in. So 13.89 times 52.7 minus 0.05 times 52.7 to the third over 3. You could simplify that a little, like do the 0.005 divided by 3 first if you wanted. Not that it's going to make it any easier. And then I plug in the 0 now. Which oftentimes, remember I said that this is going to go to 0. So if you recognize that as when I plug in 0 here, this whole thing's just going to become 0. You don't even really have to show the substitution. You could just say minus 0. Just don't forget about it though, because sometimes when there's e's involved and there's exponents, those zeros aren't going to go away. So just be aware of that. So then when I actually go ahead and subtract these, and I multiply by the 52.7, plug in, subtract, I end up with $488.06. And again, this is an approximate because I rounded. But that's really what we're looking for. So that's a consumer surplus. So that's the additional amount of money that consumers were willing to spend but didn't have to spend. And then if we look at the producer surplus, so that's the next one here, and the last part. And remember, you could have done steps 2 and 3 in any order. It doesn't have to be like this. Once you know your equilibrium point, it's basically just integrating. It's just plug into these formulas and integrate. There's nothing special about it other than you have to find the equilibrium point. So then we have our producer surplus formula. So from 0 to x sub e. So it's going to be the price minus the supply function. So we plug in everything we know. So we have 0 to 52.7 again. So it's the same setup. We have 11.11 to start the price minus the supply function. So the supply function's that 0.004 x squared. And now we can go ahead and integrate. So it's going to be 11.11x minus 0.004x to the third over 3. One thing to keep in mind too, when you're doing the producer surplus, since you're subtracting off your function, make sure that if it's a function that has multiple terms that you distribute the negative. In this situation, I didn't have to worry about it, but other times, make sure you remember to distribute that negative. So just be aware of that. So maybe putting parentheses, making it 2 steps might be helpful. So then once I integrated here, I'm going to keep my bounds. And then I just plug in. So I have 11.11 times 52.7 minus 0.004 times 52.7 to the third, all over 3. And then from there, we're subtracting off, plugging in 0, which again, you're probably seeing that as that's just going to equal 0 because it's just a number times 0. And then again, another number times 0 to the third. So it's just going to end up being 0. So that just goes away. And then when you type this in, you get a number for that. I ended up with $390.35. Again, it's an estimate. It's rounded because I rounded those equilibrium point values. But this right here is your producer surplus. So this represents the amount of money that producers gained. So consumers spent more money than producers were willing to accept. So this is the gain that the producers got on the situation here. So on the sales. So that's the extra money. So really in this section, it's just taking these 2 new formulas and you have to do a little bit of work ahead of time to get the equilibrium point, but then once you get that, it's just plugging into these formulas, getting a number, and then interpreting it. So if you have questions, save those for next class, and we'll stop with this section and you can go on to the next one.